Today, we're going to be applying ratios to probability. Short and sweet little lesson. We will learn how to find theoretical probability and experimental probability. The probability of an event tells you how likely the event is to occur. Probability. What is the chances that this thing will actually happen, this event? An outcome is the result of a single trial. For example, the rolling of a dice one time. There's 6 numbers on a dice, 1, 2, 3, 4, 5, 6. That would be called a single trial if we roll the dice one time. An event is any outcome or group of outcomes. So we could roll the dice once, twice, 3, 10 times, however many times. This would be an event, okay? So the formula for theoretical probability is probability of some event, no matter what it is the number of favorable outcomes divided by the number of possible outcomes. 2 quick, easy examples. Let's talk about rolling a dice. On a dice, you've got 6 numbers, numbered 1 through 6. The probability of rolling a 2, since there's 1, 2 on the dice, and there's 6 total numbers on the dice, would be 1 out of 6, which would be about 17% probability of rolling a 2, because one of my 6 numbers is a 2. But for example 2, like the probability of rolling an even, there are 3 numbers on the dice that are even, 2, 4, and 6. So there are 3 numbers that would give us a favorable outcome divided by 6 that would give us our total number of outcomes. 3 over 6 reduces to 1/2, or 50% probability of rolling an even number. Okay? Very different probabilities, 2 different scenarios. I think it's worth mentioning here that probability only occurs from 0 to 1. 0 probability to 100% probability. Okay? 0 probability is the probability that an event will definitely not happen or impossible to happen, like rolling a 7 on a 6-sided dice. There's not a 7 on the dice, so there's no chance that you're going to roll a 7 on a 6-sided dice, or 0 probability. We just seen 50% probability in our example 2 that we just worked. But another good example would be like flipping a coin. If you flip a coin, you're equally as likely to flip a heads as you are a tails. Or you would have a 50-50 chance of flipping one or the other. Equally as likely and equally as unlikely. So that would be 50% probability. The number 1, if you are certain for the probability to take place, then that means there's a 100% chance that that probability will happen. Like rolling a number less than 7 on a 6-sided dice. All the numbers on a 6-sided dice are less than 7. So therefore, if you roll the dice, you're definitely going to roll a number less than 7. So you are certain to get the probability, 100% probability on that example. So it would be 100% chance of rolling a number less than 7. Okay? All right, that's a good way to look at it right there with a number line. The last thing we're going to talk about today is experimental probability. Experimental probability is the number of times an event occurs divided by the number of times an experiment is actually done. All right? Number of times an event occurs divided by the number of times the experiment is done. Example 3. After receiving some complaints, a bicycle manufacturer inspects 1,000 bicycles at random. The manufacturer finds no defects on 992 of the bicycles. What is the probability that the bicycle selected at random will have no defects? and I messed up my last sentence here. We're going to write this probability as both a probability and a percent. I've already got this one worked. But if 992 of them are good, that means that, and if we ease back up here and look at our formula, the probability of getting a bicycle that is not defective would be 992. So my top number would be 992, and we inspected 1,000 total bikes. 992 over 1,000 reduces to 124 over 125. Quick discussion here about this number. That means out of every 124 bicycles we looked at, or every 125 bicycles we looked at, 124 of them had no defects. Now that's a pretty good number, 99.2%. All right, that, guys, is probability with ratios. So great job, and we'll talk about it a little bit more in class tomorrow.